Hey everybody, it's Miss Smith. So today we're going to talk about how to do math with significant figures. So yesterday we talked about how to identify significant figures. So if you haven't mastered that skill yet, go do that first. Go back and look at yesterday's again. Watch the video again. Find stuff on YouTube. Ask me a question, because if you try to attempt today's lesson without understanding what we did yesterday, you're not going to do very well. So let's go ahead and let's go into our notebook. And we're going to make a new page here. Now luckily there's only 2 rules when you do math with significant figures. All right, so on addition and subtraction, the rule is the same. You are going to look at what's to the right of the decimal. Now I'm going to make sense of this in just a minute. What's to the right of the decimal. Okay, so yesterday we talked a little bit about what significant figures are used for in the first place. It's all about accuracy, okay? So what it is, let's say, for example, let's say that you went to the lab and you weighed something out. Okay, let's say that you weighed something out and you had 3 different types of scales, and one of them gave you 100.07, 100, and 100.07568. Okay, so let's say you get 3 scales. So what makes the most sense and what's the most accurate is this one here. This last one. This one's the most accurate. But if you're trying to do things in chemistry, and you're trying to, I don't know, do research or something like that, your data needs to be consistent. So you cannot be more accurate than your least number of significant figures. So this is what I would have to look at, is that whole number. All of my data would have to be reported in a whole number. Okay, so it's about the accuracy and precision. All right, now even though this may be more accurate, how I report it and how I give my data, if you're doing research and give your data to someone else so they can use it, is you cannot be more accurate than your least amount of significant figures. So anyway, let's go on how to do math with significant figures. So example 45.01 plus 0.00214 plus 45 that's a 5.0124. Now again, you cannot be more accurate than your least amount of significant figures. So the first step on doing any kind of math function with significant figures is figure out how many significant figures you have. Now, because I'm doing addition, I'm only looking at what's to the right of the decimal. Because I'm doing addition, the same thing is the same for subtraction. So right here, I have 2 significant figures to the right of the decimal. Now, I wrote a little 2 up there on top. That is notes for myself. Anytime I work these problems out, you'll even see my paper where I have done this myself. This will help you out a lot if you're writing it up above your number. Now we're doing this electronically, so you know, it may be a little difficult, maybe a little bit too much to ask, but I mean, I'm not going to look for that. I'm looking for the correct answer is what I'm looking for. I'm not looking for your work on this necessarily. All right, so let's look at this one here. Remember, these zeros are leading zeros, so they don't count. So this is 3 significant figures. This one here, this 0 is a sandwich 0, so it counts. That is 1. Oh, we're only looking at what's to the right of the decimal, aren't we? So let me back up a little bit. Again, so this one's still only 3 significant figures to the right of the decimal. And then this one, this is only, oh, that's the answer. Oops. Okay. So that's the answer. Okay, so in your calculator, when you put this together, your real answer in your calculator is 45.0124. Sorry, y'all, I didn't look at the equal sign there on my example in my notebook. So that's the real answer in your calculator. So when you basically, what this is for, the other purpose of this and why I really teach this, the reason why you need to use it, is so you know where to round. You don't have to ask me anymore, Miss Smith, where do I round to? According to these rules, it tells you exactly where to round. So you don't have to ask that question anymore. So we know that our answer can only be have the same amount of significant figures as the least. Okay, so we're going to look at the least of what we got. So this part of my equation only has 2 to the right of the decimal. This one has 3. So we can only be as accurate as our least. So our answer needs to be reported to 2 significant figures after the decimal, because we looked at the decimal here, we looked at the decimal here, so our answer needs to be looked after the decimal there. Now, because this is technically a sandwich 0, that 0 does count as significant. So what I'm going to do is I'm going to go to my second significant number and I'm going to stop. So I like to draw a little line right there. That's where I'm going to stop. Now what I do, regular rounding rules apply. So this is where I'm stopping. I'm looking at this. Regular rounding rules, if that is a 5 or above, then this answer would be 45.02. But because that is a 2, then our answer is 45.01. Now that is recorded to the correct number of significant figures. Now I know I'm moving super fast, so I'm going to do several more examples for you. So 976.901 minus 400.09. Okay, again, this is subtraction. The rule for addition and subtraction are the same, so we're looking at what's behind the decimal. Here, that's 3. That's a sandwich 0, that 0 counts. Here, that is 2, because that's technically a sandwich 0, so that counts. We are going to choose the least of these to report our answer to. So our answer will have 2. So get your real answer in your calculator. The real answer in the calculator is 576.811. Now we need to round it and report it to the correct number of significant figures. So we decided that we need to have 2 numbers to the right of the decimal, because this is a addition subtraction. We're only looking at what's to the right of the decimal. So I go to the second number to the right of the decimal, and that's where I stop. I look at the number after it. It is less than 5, so that means that it stays the same. So my answer is 576.81, and that's our answer. Let's do one more with addition and subtraction. 0.0397 plus 0.010. Okay, so we're looking at what's to the right of the decimal. This 0 is a leading 0, so it doesn't count, so it only gives me 3 to the right of the decimal. These are leading zeros, but that 0 at the end is an ending 0, and I have a decimal physically present, so that is 2. So we are going to choose the least of these between the 3 and the 2, so it's 2. So our answer needs to be recorded to 2 significant figures. So the real answer in the calculator is 0.0497. And so what we're going to do is, because we're recording it to 2 significant figures, we're going to go to the second one. That's where I'm going to stop. I look at the one after it that is above 5. So that means that 9 needs to go up. Well, the next step up is 5. Now, 0.050. This is where some of you would probably leave it. Now, remember, I'm supposed to have 2 numbers that are significant to the left of the decimal. Well, these zeros to the left of that 5 don't count. So as of right now, my answer is only 1 significant figure. But if I put a 0 out here, then I have 2 numbers to the that is significant in my answer. Okay, so that's how you do addition and subtraction. So let's move on to multiplication and division. Okay. So up here, we looked at what's to the right of the decimal. We are now going to be looking at the entire number. All right, examples. Okay, so now we're looking at the whole number. In this whole number, there's 3. In this entire number, there's 3. So that means that my answer needs to have 3 significant numbers in the whole thing Before, we were only looking at what was behind the decimal in our answer. But now, because we're looking at the whole number, we also have to look at the entire number for our answer as well and record the whole answer to that. So in the calculator, this turns out to be 0.061132. I need 3, so I'm going to go to the third significant figure. That's where I stop. I look at the one after it. It's above, it's below 5, so it stays where it is. So our answer is 0.0611. Another example, 45. Oh, I've got all my colors messed up. 45.11 divided by 5.55. Okay, so remember we're looking at the whole number. This is 4, this is 3. We're going to choose the least of those and report our answer, the entire answer, to 3 significant figures. So in your calculator, the real answer is 8.12792798828. Oh, 928. Okay, so I go to the third number, that's this one here, and I stop. I look what's after it. It's above 5, that's 7. It's pointed at the 7, not the 9. So that means above 5, so my answer is 8.13. Okay, one more. This one's a little tricky. Okay, so let's look at how many significant figures we have in the whole number. This one, 1. Those are all ending zeros. There's no decimal in sight, no decimal physically present. So that means it's only 1 significant figure. This has only got 1. Ooh, excuse me. So that means my answer only needs to have 1. Well, the real answer in your calculator is 2 million. Okay? And you could leave it like that because technically that's only 1 significant figure. But there's another way to write this, and it's still only be 1 significant figure. So that's 2 times 10 to the 6th. Because anytime you're looking at scientific notation, significant figures with scientific notation, you're only going to count what's up here. Like the rest of this doesn't count towards your number of sig figs. So like so let's say that I needed my answer to be 2 significant figures, and I wasn't doing it in scientific notation, this would technically be 2 significant figures because of this right here. Because it's a 0 with a decimal, it's an ending 0 with a decimal. All right, anyway, good luck with this. Again, if you haven't mastered yesterday's lesson, you are not going to be able to understand today's. Please go back and look at that if you don't know. If you have any questions, you know where to find me.